All right, welcome everybody. We are going to give folks a few moments to trickle in, and then we'll get started with a quick intro. All right, looks like we've got a good amount of folks joining. So thank you everyone who's joining us today for Rainscreens, the Built Environment and Achieving Net Zero. It's presented by the team at Tion Cladding Systems. We've got both Ben and Brewster on today who are going to be helping us out, sharing some information about their great products. Before we go ahead and get started with today's product presentation, I'm going to give a quick tour of some resources on Acelab. We are helping out with hosting today's event. So just going to give you some pointers for ways to access some more information after today's webinar. All right, so I will share my screen here. From Acelab's homepage, you can use this search bar to cross-search any of our product categories, manufacturers, resources that we have on the platform. Something that's a bit newer that we just added last week, actually, that's really cool that you should check out when you've got some time is our new AI Copilot search. So if you click on any one of these toggles, you can use like our specific search tools. If you use Ask Ace Anything, you'll actually be prompted back with, further questions to help you kind of narrow down your product search. So definitely recommend everybody check that out today. It's a really fun tool. Today, I'm just going to show you what to do if you know the manufacturer you're looking for. You can go ahead and start typing in the name of any brand. Make sure you toggle onto manufacturers there and then head over to their page on Acelab. From here, you can explore more about Tion. You can get in touch with their team directly by clicking this contact button. You can scroll down to view some more information about their company, watch some installation videos, as well as view their products. You can save these to your firm library on Acelab, to any of your projects on Acelab, so that you can come back and reference that information later. And you can open up these product pages to access downloads, product literature, all of that good stuff. So I'll send over a link to this page in the chat so that you can just head there directly. It's a great way to stay in touch with today's presenters, save any of the information that we're covering in today's webinar into your firm library on Acelab, and be able to return back to it whenever you'd like. All right. Other than that, just want to quickly show folks where to head if you do say yes to our poll later on and ask to be connected with the Tion team. We'll go ahead and connect you through your Acelab account so you don't have to come back here and enter your details yourself. You can just head over to your Acelab account, click on this icon on the top right, and that'll take you over to your conversations page. You're also going to get an email about any new conversations that are started. You can navigate to this page directly from that email as well. But just in case you're, logging into Acelab and want to take a look at an overview of all your conversations, this little button in the top right here is always going to take you to your conversation tab. All right, I will stop there. It looks like we've got a good amount of folks in the room. So other than that, I just want to really encourage folks to please ask questions throughout today's presentation. We'll keep our eye on those, hopefully get to some live towards the end of today's webinar. If we don't get to your question live, we'll have a record of it and we can follow up with you after today's event. And last thing that I mentioned, there will be a quick poll towards the end of the webinar as well. If you're interested in connecting directly with today's presenters, you have a project you want to talk to them about, you want to access some more resources about their products, feel free to just fill out that poll, give us a few quick details. We'll go ahead and connect you with today's presenters so you can get all the follow-up information that you need. All right, that is it for me for now. Ben and Brewster, whenever you're ready, feel free to share your screen and go ahead and take it away.
All right, sounds good. Thanks, Bo. I will do a quick screen share here. Hang on. All right. Let me know if you can see everything here.
We can see everything. You might just want to pop it into like presentation mode. Yeah.
Here we go. There we go.
Perfect.
Okay, good. Well, thank you, everyone, and good morning or afternoon, wherever we're catching you from. I'm Brewster Crosby. I'm the president of Tion Cladding Systems. And also with me today is Ben Horn, who's our director of global sales. We're going to kind of split the presentation here. I'm going to do the first part a little bit about Rainscreens and the built environment, and then Ben's going to talk a little bit about how our system sort of plays into this realm. Do you guys, let me just move this here. So just quickly, Tion Cladding Systems is a cladding attachment device. And what we do is we work with any really type of substrate and any type of panel and pack everything in the middle, within our system, behind the panels and in front of the substrate wall. And we would typically consider ourselves a high-end Rainscreen product. And that's important because a high-end Rainscreens product is going to derive certain advantages in the built environment as you try to reach towards more efficient buildings. So a high-end Rainscreen can get up to 40% energy savings in a building. You can put any type of panels on a high-end system, including solar panels, which would generate electricity for the building. Our panels or our system comes prefabricated off-site, so it saves time and further carbon in the construction process. It also meets and exceeds all net zero building goals really defined by New York City. And it is ready for the market today, which is really a multi-million building upgrade that's required just in the US alone. 1 second, change slides here. So what is net zero? I'm sure by now almost all of but net zero is really the goal of balancing the inputs and outputs of our environment. In this particular instance, it's in the built environment. So effectively getting our cities to be zero carbon and emit zero carbon. If it takes in carbon, we're trying to have offsets, so the net is actually zero carbon out into our environment. Many organizations, building owners, cities, counties, states, countries have all signed on to this. And it was really developed in 2016 as part of the Paris Agreement. And the United States has sort of been on and off again with this. But the good news is that this at the state level and at the city level, we're seeing really strong commitment from key cities and key leaders and key states in the United States. Here's just a listing of some of the cities that have committed to net zero. And it's really aligning around a lot of the New York City standards, which I'm going to touch on here in a little bit. You see here a handful of cities highlighted on the map. On the left-hand side is a whole bunch of other cities. More have followed. Canada, all the major cities are listed in Canada. Canada actually approved a countrywide initiative to achieve net zero. And so a lot of their buildings are going to need to be upgraded and retrofitted as well to achieve those goals. Many of you probably already know too what the built environment is, but achieving net zero in the built environment really is just saying we need our cities and our transportation and all the surroundings that are quote unquote human made really to achieve, that's the built environment. So factories, buildings, towers, parks, trains, planes, automobiles, all those are the built environment. And the net zero goals are really trying to get all those to achieve zero emissions. And so it's a colossal task across the spectrum, but also just within the cities and how it relates to buildings. If you look at just businesses, federal, state, and local governments, they own or use 93 billion square feet of real estate in the United States. And that is about 190 billion in energy expenditures a year. So we're talking a significant amount of volume and a significant expense in what our buildings use to function. It's about 35% of all energy consumed in the US, and it's about 16% of our emissions as a country on a whole. So you look at the footprint of the built environment, and it's actually pretty substantial when you think about all the outputs. The interesting thing is when you actually look at how a building functions, a good hunk of it, about 40% of it, actually relates to the building envelope. And that's the heating, the cooling, and the ventilation. And these are all things that are relatively manageable in an existing building or in a new building that you create just by products on the market today and retrofits. So how do you achieve net zero in the built environment? There's a whole bunch of things people can do and cities and states can do. Of course, not everyone's going to do the entire list. People are going to kind of mix and match for what makes sense for them, both for their part of the built environment, whether it's a building or a park, or their economics. So the main thing, obviously, is to decarbonize the energy sources. So shift from coal and gas to cleaner energy sources like wind and solar. That is a big one. Part of the challenge there that cities are finding is that they don't have the footprint to do wind and solar within the city. And so we're looking at ways, and we'll talk about this a little bit later, on how to help cities actually generate electricity within their footprint. Building efficiency, so updating your buildings and hitting new codes that have been implemented so that all the buildings, existing and future, are much more efficient. Sustainable transportation, we hear a lot about this, and many of us do this already, from biking and walking, using electric cars. All this helps, again, reduce the carbon needed for us just to go about our daily lives. Green infrastructure, I know this is a huge field within urban planning right now and architecture, but this is really developing more green spaces and utilizing existing spaces in cities. So that's green roofs or adding solar and wind to roofs and facades. Waste reduction and recycling, I'll touch on this in a little bit, but if you think about an existing building, there is a bunch of carbon that was used not only in the material that's in that building, but everything it took to build it. Whether it was a year ago or whether it was 100 years ago, carbon is stored in that building. So if we decide to recycle that building or actually upgrade it as opposed to tearing it down, we actually aren't necessarily creating more carbon. We're keeping that carbon stored and then utilizing that versus tearing it down, dumping that carbon in a landfill, and then using carbon to rebuild something new. So waste reduction and recycling is important. Adaptation measures. This is something that we hear more and more about, of course, both in design and in city planning, where we are looking at designing buildings a little bit differently and our urban footprint differently to deal with rising sea levels and more extreme weather events. There are carbon offsets and removal opportunities out there. And this is really where, again, if you're in a city, economics oftentimes drive your building choices and your building designs. But there's ways to work with other organizations that will let you invest or do offsets with projects that are perhaps in a different state or different region. The good news is that policy and regulations and community engagement and education are all sort of moving forward in this, and cities are starting to push harder on getting upgrades done, and that's coming in part because of the community engagement and the education. So all the awareness that's coming from the populace of these cities and the business leaders and politicians are starting to see the value and the need to do this. And then, of course, partnerships and collaboration is very important across multiple agencies. If you're, cross-discipline in cities and governments, to other types of organizations like RAINA, which is the Rainscreen Association in North America, and Passive House Institute. Organizations like this are really helping drive the conversation and provide the tools needed for people both on the design side, but also on the construction side to help achieve net zero goals. Quickly, the Rainscreen is probably the most efficient cladding system out there to help achieve better energy performance. And it really increases both the warmth of the building, but also how air moves in and out or through the spaces of a building. The components of a Rainscreen are relatively simple. Of course, you have the substrate, which is the load-bearing frame, typically the side of a building. You have a water barrier that provides for the waterproofing, so no water can penetrate into the building. Insulation typically sits outside the water barrier, and then you have an attachment system. The attachment system is actually relatively important. There's many different types of attachment systems. There's the typical lattice system that you would see, where you see verticals and horizontals. Tion actually is a more of a vertical system, which allows for more airflow to go through the air cavity that sits outside the attachment system before you get to the cladding system. This airflow is really important because it allows the exterior of the building to breathe, and hot air is moving, kind of through the exterior envelope of the building and out, as opposed to trying to penetrate into the building. And it's the reverse in winter. And then, of course, you get the benefits of your exterior cladding, which provides, all the environmental benefits and protections to your building, along with noise and other features. The advantages of a Rainscreen, really, if you think about wearing a down coat like many of us do, is an increased R value and U value. The R value is effectively putting more feathers into your coat to keep your building more warm. The U value is having a stronger exterior shell, the nylon shell, to keep the ability for the weather to penetrate into your body. And so a really good Rainscreen is going to increase your insulation and decrease the ability for wind and other factors to penetrate the building. So you get the benefits of both energy efficiencies in a building with a strong Rainscreen. We're seeing this throughout. Good Rainscreens across various locations are getting up to 30 and 40% efficiency, additional efficiency for a building. This map just shows New York City, and what you see in red actually are underperforming buildings, and New York's analysis of how many buildings in New York need to be upgraded to hit code. And you can see effectively all of Manhattan and much of into Long Island there that you have to have these millions of buildings that need to be upgraded. But the savings are real. If you can save 30 to 40% on an energy bill through your upgrades, it's pretty substantial for a building owner. The other nice thing about a Rainscreen and cladding is it allows, from a design perspective, to add color, add texture, do quite a bit of kind of fun design things to really freshen up a building or create new design features. We're seeing so much advancement on the panel side, the cladding side of facades, both in the materials that are now available, the colors that are available, the ability to really have strong UV performance, strong rain environmental performance is increasing all the time, and it's just fascinating to see how advanced a lot of these panel companies are getting with the materials that they're able to provide. I touched on it a little bit earlier about the importance of actually reusing existing buildings, because if you look at an existing building, there is all that captured carbon in there already. If you tear it down, you lose all that, and you have to create a bunch of more carbon to build something new. And so what we see here is, just by simply recladding a building and putting a Rainscreen on the exterior, in this case of a brick building, you can get all those benefits of a cladding system, of a Rainscreen system. So you're going to see your R value goes up. You're going to see your U values go down. You're going to see better waterproofing. The other ways people are really focused on upgrading their buildings, obviously, are the other sort of heat loss areas, which are the windows and doors. And then they're upgrading their HVAC systems too to provide more efficiency in the interior circulation of a building. But really, for a square foot perspective, a reclad is one of the best ways to update your building. We see this more and more in Europe, and it's starting to happen a little bit more in the US, where people are experimenting, and Tion is doing this as well, with putting solar panels on the side of a building as the cladding component. And the really interesting thing about this approach is, one, you get all the benefits, energy saving benefits of a rain screen, so 30–40% savings to the building, but then you also get energy generation. And so that allows both the building owner to have a revenue stream, but also if you look at the footprint of a city, suddenly you have more real estate and more vertical aspect to generate renewables, as opposed to pulling carbon energy from faraway sources, whether that's coal or gas or what have you. The cities around North America are really focused on this. New York has been one of the leading cities on the drive towards net zero. Their goal is to do it by 2050, which tends to be about the 2040, 2050 tends to be about what most cities are driving towards. But the task is huge. So New York has set a series of laws in place to both sort of use carrot and stick approach with their building owners. They're giving them time to update their buildings, but if they don't, they have to start to pay more. And the fines that they end up paying will increase each year that they're late on updating their building until 2050. But if you just look at New York alone, there's over 1 million buildings in New York that need to be upgraded or retrofitted. And as I touched on, you can do this through, a whole host of ways. Updating windows and doors is important. Updating your HVAC system is important, but also doing a rewrap and updating your facade will really help you get to achieve those goals. New York really, as I said, is a leader here, but Boston's followed, Chicago's followed, a lot of West Coast cities have followed, and all the way into Canada. So, we're really talking millions upon millions of buildings that need the support to achieve these goals. So in kind of closing on the net green side, net zero side, and passing over to Ben to talk a little bit more about Tion, what a high-end Rainscreen system does, such as Tion's system, is really connect all the dots. So, Tion works with all substrates. We're designed to have minimum water penetrations to keep waterproofing of a building as strong and as good as it can be. Most systems work with various depths of insulation. Tion will go out to 12 inches of exterior insulation, which is needed in parts of Canada and even parts of the US. We can span deck to deck too. So a lot of systems go from stud to stud. Our system does that, but we can also go deck to deck in 10 to 12 foot spans, which is helpful for some reclads depending on the building and how the building has been structured from years ago. We manufacture everything off site. So our product shows up in one piece, designed for a specific location on the building, designed for a specific panel to match up with. And so that really saves a lot of the carbon intensive part of a job site. If you think about, every day someone has to drive to the job site. If you think about all the time someone goes up and down on a lift to put in a lattice system, all that is creating carbon. And that's all sort of in part of the carbon cost of doing a building. So if you're able to reduce that by sending completed products to the job site, you're actually lowering the carbon inputs into both a reclad and a new build. Many cladding systems, including Tion, are designed to meet the codes in the future and really help the cities achieve their goals as well. And, you know, we're, along with a lot of the other cladding companies and a lot of the other panel companies, all really driving to help cities and designers and building owners achieve net zero by 2050. And I'll hand it over to Ben. He can talk a little bit about how our product works so you guys can get a better understanding of that, and then we can circle back to questions if there's questions on anything later.
Awesome. Thanks, Brewster. Yeah, so again, my name's Ben Horn, Global Sales Director for Tion, and I'm going to jump into the product specifics, how our system works, benefits, all the stuff that is really kind of more project specific. And let's see here. You guys see my screen okay?
Yep.
Yep, good. Awesome. So a little background on Tion, kind of where we came from, how we got to where we are today. Really started out of a relationship with Apple years ago and working on a lot of their stores around the world. And they were primarily utilizing GFRC and quartz panels on a lot of their interior cladding and exterior cladding. And what they were utilizing was, like still a lot of people out there today, is some sort of a cleat or Z-clip or French cleat or something like that on the back of the panel. Then there's something on the wall corresponding. You put the panel on. If it's not right, you take it off, you shim it, you mess with it, and it can take a while. And so what we came up with was a way to actually adjust those panels up, down, in, out, any which way you want while they're on the wall. And so not only does that significantly cut into the installation timeline, but it also allows for perfection with the aesthetic appeal of the finished product. So your joints are perfect, your panels are all perfectly in line. And I think from, you know, an architectural standpoint, it's obviously the desired effect, right? You want everything to look perfect, like you drew it up on the computer. So that's kind of where we came from. And I'll kind of get into a little bit more, like I said, of the specifics here. But basically, you know, we do all of the engineering, all of the shop drawings, coordination with the panel manufacturer, with regards to creating piece tickets. And so we're really kind of a one-stop shop when it comes to a fully furnished, you know, stamped approved system. You know, there's several reasons why our system is more high performance than others out there, and I'll get into that here in a second. But I think one of the big things to take away is not only the adjustment capabilities of our system, but also the amount of on-site time we significantly cut out. And primarily that's because of the fact that our system comes already fully assembled, like Brewster talked about. And I'll show you that more in a second in comparison to another system that isn't. But there's, you know, several other ancillary, you know, benefits of our system too, with regard to the fact that we can space our hangers out so far. There's fewer penetrations through other kind of weather barrier. Our thermal performance is much better. So yeah, there's several reasons as to why, from a design standpoint, our system makes a heck of a lot of sense. So just kind of showing you what our system looks like, right? And I'll dive into this more, but really, what you see here on the right is what we call our T hanger, which I would say we probably use 90% of the time on projects. What it is several extrusions that we assemble, customized to the panel geometry of the project. And I'll kind of get into a little bit how we determine some of that in a second. But basically, like I said before, this comes as one piece. So you can see these are mounting brackets that attach to the substrate, and then this is the body of the hanger. And then in this case, we really just have some simple Z-clips, and I'll show you, there's several different attachment methods. You know, we can work with just about any type of panel and engineer any kind of connection to that panel. On the left here, you see this is our steel hanger, and we use this for relatively heavy panels. So, you know, this aluminum hanger here is rated for about 850 pounds. So if, you know, with two of them with a panel, you're looking at almost 2,000 pounds typically. And this is in excess of several thousand pounds. So there are some cases where this comes in handy, and I'll show you an example of that. But back to the attachment methods, I mean, there's several different kinds, and a really basic kind, depending again on the panel we're working with, but some sort of an undercut anchor. These are Kyle anchors, and basically they just get drilled anchor holes into the back of the panel, and then you can attach some sort of a real basic Z-clip or some other type of extrusion that then again would marry up to this clip on the front of our hanger. And again, we do all of the coordination with the panel manufacturer. So when the installer receives our hangers, these clips are exactly where they need to be to line up perfectly to these clips on the back of the panel. So I'll show you, this is another type of attachment. This is a much more robust type of attachment. We do a lot of GFRC work where maybe the panel itself has like a tube steel armature attached or poured into the panel. So you can see this is the panel here. This would be our hanger attached to whatever the substrate is, in this case, some tube steel support. And then you can see here this hook right here really just sits into a notch that's cut out of the tube steel on the back of the panel. So this is another, more robust attachment. But this is just an animation basically kind of showing you what that installation looks like. So you have the panel or the hanger attaching to whatever this substrate may be. It doesn't matter for us. It could be CMU, stud walls, whatever. And then that pink stuff coming in would be your continuous installation if necessary. And then you have the panel here with the clips on the back that just engage with the clips on the front of the hanger. And it's that simple. So, that's a really basic animation of what a large format panel installation would look like. To show you kind of the adjustment capabilities here, this is a mock-up we did with Apple years back, and just showcasing some steel, or sorry, some quartz panels for them using our steel hanger. And we use this hanger on a much bigger panel that I'll show you here in just a second. But in this case, just attaching directly. And then we have our adjustment bolts on top of the hanger. So by turning that bolt right there, you can see the entire hanger moves in and out at the top. And then the middle adjustment bolt raises that entire hook plate up and down. And you can see in this case, we're using some laser cut hooks as opposed to like a Z-clip, for example. And then the adjustment bolt on the left, a little zoomed out, but you can see at the bottom, it's moving that entire hanger in and out. So again, you never have to take the panel off to shim or mess with it in any way. All the adjustment is located at the top of the hanger, and you can see the panel just sits on those hooks, and you can see how easy it is to adjust that panel. Obviously, in the real world, nothing is ever perfect with regard to framing, or, especially if there's a situation where the building is being refurbished or reclad, things settle, things get out of whack. And, it's really hard on the installer to achieve perfection with regards to panel alignment. And so our system has built-in adjustment to it to really work with any type of, inconsistencies with the wall. So it's an installer's dream. And again, from an aesthetic standpoint, can fix a lot of issues. So just to touch on exactly how perfect we can get things. This is the biggest Apple store in the world in Dubai. It's at the base of the Burj Khalifa at the Mall of Dubai. And if you're ever there, go check it out. It's a pretty amazing building. But just to give you a sense again on scale here, these are people. So you got about these 40-foot tall sunshades that rotate with the sun. And the entire interior and exterior of the store have GFRC panels supported with our hangers here you can see in blue. And basically you have an upper level and a lower level, and then there's two stairwells on either side. And this picture is a shot of there's some stairs, there's a little landing, and then you go left up the stairs to the second level. And so in this case, we're just attached to Unistrut, fairly simple way to deal with it. The attachment, and these hangers are about 20 feet tall, 18 feet tall. And you can see the panels here. These are several thousand pounds. There's tube steel all in the back of this to support the actual panel. And what they did was poured the actual handrail into the panel. So you can see these are all individual panels. You can see their joint lines. And this is a shot looking down one of those stairwells. So this is an intersection of 4 of those panels. And the tolerances we had on this project for the joints were 3 millimeters. So we had a guy from Apple, from Italy show up with a piece of blue plastic, and he checked every single joint line around the entire store. And he would say, this panel's got to go up 0.5 millimeter, because if that's not perfect on your hand, you're going to feel it. And we had the ability to get back behind the wall, because it was open in this case, and adjust those panels to those type of conditions, it's pretty amazing. So I don't know of any other system in the world that can do that, but if you do, let me know, and I'll have my lawyers reach out, because all this IP is wrapped up pretty tight. So the adjustment capabilities of our system are pretty slick. One thing I just want to show you here, and I don't know, what everyone's depth of knowledge is with regards to the actual installation process. This video we made, and I'll just blow through it a little bit here, but basically what we did is we took another system that is your more traditional kind of clip and rail system, and just installed two 5-foot by 5-foot panels on it. And we did the same thing with our system. And we just wanted to showcase the difference in time. So basically what you're doing is you're building that out on the wall. Okay, so this is the system on the left, the competitor system, and you have your clip and rail system, and then we have our hangers here. And these are 10-foot hangers, again, two 5-foot by 5-foot panels. So we're able to put, both those panels on the same set of hangers. And so basically what you're looking at.
I'm not sure I'm seeing, yep.
Sorry.
That's right.
Let's see here. I'm not great with the, here we go. Sorry. Zoom. I'm normally a Teams guy. Okay, sorry. Here we go. How's that?
That's great. We got you.
Okay, sorry about that, guys. So basically, let me go back here. This on the left is what you build out with your clip and rail system, kind of competitor system. And this on the right is our system. Just again, the two vertical hangers, 10 feet tall, two 5-foot by 5-foot panels on each one, or on the set, sorry. And so basically, as an installer, what you get is here in the foreground from a competitor, you get a box full of components. You got your clips, your horizontals, your verticals, your shims, your fasteners, and you essentially go construct that on the wall like a Lego set almost, right? Our system, again, in the background, comes fully assembled, ready to go. Literally all you're doing is pulling that hanger out of the crate and attaching it to the wall per our shop drawings. If you look at the left here, you have 38 individual pieces that you have to cut, measure, and again, build out on the wall. You have 72 anchors, there's shimming, you got to get everything all plumbed out. Our system, there's two things, and there's, you can see here 3 mounting brackets, 1, 2, 3. Once we hit about 8 feet, we had a third mounting bracket in there on our hangers to, for engineering purposes. But typically there's, 4 fasteners per mounting bracket. So you can see there's, a third the amount of mounting brackets. And again, no shimming, no cutting or anything like that. And then again, obviously with the panels, depending on the panel, there's a lot of potential stuff on the back of the panel that has to go on to marry up to whatever it is that the system you're working with. So this just kind of shows the sequence here of really the process of installing this stuff. And if you've never experienced the actual installation side of things, it's a very labor-intensive, tedious process. And these gentlemen here in this video have worked with both systems, so it's not like me up there fooling around. They know what they're doing. But it just goes to show again the amount of labor it takes. And this is 50 square feet, right? So it's not, when you're thinking about a large project, really that much square footage. But again, there's a lot to it. So at the end of the day, it took them 151 minutes to put those 2 panels up on the wall with the competitor system. And fast forward here a little bit, but basically doing the same thing with our system. What we've done by sending everything already assembled is kind of take a lot of the guesswork out for the installers and the ability for them to make some sort of a mistake on the, putting everything together. So everything is in the right place. The adjustment capabilities are built in. All they really have to do is attach the hangers and then drop the panels on. And, if there's adjustment needed, it's all built into the product. So that took, 35 minutes, right? So you got the comparison there of 151 minutes versus 35 minutes. And the one thing I'll bring your attention to, 21 minutes over here of our 35, in this case, was just attaching those anchors and the cleats to the back of the panel. A lot of times there are no anchors or there are no cleats to even attach to the back of the panel, so you can see how much drastically faster that would make it. An example of that would be, let's see here, stop share, learn my lesson. Hold on, share. All right, back to this. Okay. So an example of that would be, say, if we're utilizing like a kerf. And if you're not familiar with what a kerf is, basically you have your panel and you have a saw cut down the middle of the panel horizontally, and you can attach a extrusion that keeps that piece in place. So, we've done several kerf jobs where what we have, we have these extrusions that we attach to our hanger, and then so you install it in a sequence like this, where this is a mock-up we did for a project, and this is 80 square feet. It's 10 foot wide by 8 foot tall. And so what we have here are the hangers attached to the wall. You get plumbed out, and then you come in and you attach this bottom J, which would be like right here. And then you apply the stone, and then you come down and secure it with your dovetail clip here. And then you work on the course above you. So you can kind of see that right here. Finished product looks like this. In this comparison, the installer, and I've worked with several installers and checked these numbers, and they're all pretty consistent. They were factoring in about 100 square feet of subframing system per two-man crew per workday. 100 square feet, right? That's using the other type of kind of clip and rail system. Our system, they're gonna probably be doing about 1,500 square feet a day. This whole wall took them less than an hour. And they were factoring in, again, 100 square feet a day with a two-man crew of the subframing system and 150 square feet of stone with a three-man crew coming back on top of it. They're probably going to be doing close to 750 square feet of stone with our system with that same two-man crew. They don't even have to get another crew. So you can imagine, especially in a place like New York or Chicago, LA, where the union wages are high, it's really startling how much money they're able to save in efficiency with our system. Talking about insulation real quick, this is a top-down view of our hanger, and you can kind of see, we call it a T-hanger because we have this T-profile mounting bracket that essentially pushes out this adjustment hook plate and creates a cavity right here to allow for the insulation. So this is a mock-up, or sorry, not a mock-up. This is a reclad of an existing building we did in Milwaukee. And you can see we're just attaching to grout-filled CMU in this. And again, the nice part about our system is we don't have to hit, studs. If this was a stud wall, we wouldn't be attached every 16 inches or 24 inches on center. We can space out our hangers quite a bit. And, so you can see the vertical black, those are our hangers. You can see them coming through with, I think, 3-inch mineral wool on this. We can push this out to a foot if they need to have more. We did a project in Toronto where they needed like 8 inches. So you can see it's tucked back in here, and then these are the panels right here. So they just come on, drop those panels on, and work their way on up. Good to go. So if we're dealing with large format panels, like in this example, it's pretty straightforward. You got 2 hangers, you got your panel, you drop it on, you're good to go. This is, obviously a different panel geometry that has smaller format panels. And in this case, we're not utilizing individual hangers per panels. What we'll do is we will unitize or panelize sections. So this is the Golden State Warriors arena in San Francisco. And these are 1 foot, 2 foot, 3 foot tall by roughly 8 foot wide panels. And so it wouldn't make sense for us to use individual hangers. So what we'll do is we will unitize or panelize and basically make a frame that you can see here and attach those panels individually to that frame. Hangers are already up on the wall. And then essentially the installer will just attach that larger section. Essentially, we just made a bigger panel to that to those hangers. So this is a mock-up we did. So you can see there's a hanger here, there's another hanger over here, and then we left these panels off so you can kind of see through it. But there's the black frame. And again, the installer attaches these to the frame and then flies that up as one section. It's a fairly regular job for us where it's a reclad of an existing building and it's 30 years old, had tile falling off of it, didn't look great. So the vertical hangers here, or the vertical, those are our hangers, and that's all there is attached to the exterior. All that horizontal lines, those are all existing facade features. So you can see in this case, there's scaffolding and buckets, and your productivity as an installer goes down even further. They had originally estimated using a regular system, I think about 66 days, and they ended up doing it in 16 days with our system. So you got, again, sections like this that you're throwing up as opposed to individual panels. If you go back to that video I showed you and all those other components that you have to have, clips, verticals, all that, it would take a long time, as you can imagine, to get that subframing up prior to even putting up the individual pieces. So, and then that's what it came out looking like. So just a couple more examples of projects. This is, again, the Golden State Warriors Arena Chase Center. These are all panelized sections as you go around the entire exterior of the building. One of the things that we do really well with is staging and coordination with the installer to make sure that in a situation like this, all the panels arrive in the perfect order and you're not running around the site because there's not a lot of room looking for things. So being able to deal with deliveries and all of that coordination with the installer, we do really well with as well. So some more examples of exteriors. This is a reclad in Denver. Had this kind of old, ugly, corrugated concrete look, and they gave it a facelift. Really cool light feature the architect put in here. Came out looking really fantastic. So this is Fashion Square Mall in Scottsdale. Again, similar approach from the panelization project in Portland, where we were able to actually deal with an installation issue because someone in the city or someone at the general contractor must have pissed off someone at the city because they were a quarter inch over the or half inch over the property line, I believe, with these panels. And so they came out and did a survey and told them they had to take everything off and pull it back. Well, with our system, they were able to actually get in these joints and actually adjust the panels all back. Our adjustment bolts are accessible through that joint line right there at the top of the hanger. So they can get in there with a tool and suck that panel back half an inch. Took them about a day, came back out, city didn't believe them, and sure enough, they were right on it. So yeah, that's about all I wanted to share with you. I'd love, let's see here if I can get this going. Any questions or anything like that we need to address, Bo?
Yes, there are quite a few questions. So I'll just start at the top if that sounds good, and we can take it from there. And reminder for anyone else who has not submitted a question, you can do that using the Q&A box. So feel free to go ahead and submit a question now. We've got about 12 minutes to answer some of those. All right, first off, do you have a 3-part CSI spec and BIM and CAD details?
Yes, on both. Absolutely.
All right.
I don't know if those are shared through our page on Acelab, but if not, I can distribute however that needs to be done. But yeah, so edit files, any type of CAD files, and then yeah, 3-part spec, of course.
Perfect. Awesome. I know we have the specs on Acelab, so y'all can access that with the link we shared. CAD files, I'm not sure. I don't think we have those actually on the site. So feel free to use that poll that's up now. If you want to request CAD details, BIM files, feel free to just type that in there and we'll get you connected with Ben to get that over to you.
Sure.
All right. Next up, is the T thermally broken?
I'm sorry?
Someone asked
yes.
if the T hanger is thermally broken.
Correct. Yep. If that's a requirement on the project, we can absolutely provide, the thermal isolator pads. We have, a couple different sources for those things. But yeah, just put that in between the mounting bracket and what we're attaching to, and then there's the corresponding hardware that goes along with it. And yes, thermally broken.
Awesome. Next up, where is the Toronto project?
Toronto project on what's it? It's in the the design. It's a YSL store in the design district part. I can't remember what's the name of that street, Brewster. Like Blue.
Bloor, Bloor, I believe, Bloor Street.
Or okay, yeah. So it's the new YSL store, and they're large GFRC panels. They're kind of like ribbed, if you will, and it's on that main road there with all those other high-end retailers. So we do a lot of work with high-end retail, both exterior and interior. You know, our system obviously was originally designed for interior cladding, but most of what we do now is all exterior work. But yeah, if you're in Toronto, go check it out. Beautiful store.
Awesome. All right, next up, do you tape the joints between insulation boards, and is there airspace behind the insulation board?
So do we tape it? I guess I'm not totally sure. But yes, there's airspace, of course, for the airflow, right? So if we're dealing with, you know, 2, 3, 8-inch, whatever the installation thickness is, our T-hanger mounting bracket, again, pushes it out past that, right? So whatever type of airflow cavity you want, we can achieve. Typically, it's around an inch from what I see. And then if you're wondering if I caught that with the taping, so whether you want an open joint, closed joint, I mean, we can really deal with anything. It's totally up to the design, really. And as far as taping of the insulation, you know, we really don't deal with the installation of the insulation. But I think there's different ways to do it. So I would probably defer to whoever's doing the installation of the installation, however they do it.
All right, next up, is it challenging finding qualified installers in locations outside of major metropolitan areas? We frequently run into the lack of qualified tradespeople around the Jackson Hole area where we have a lot of our work.
I have relationships with really large, you know, national installers that typically will go anywhere I ask them, as long as it's, you know, cost, you know, it's not cost prohibitive for them. The beautiful thing about our system is it's not hard to use at all. I mean, I hope that was conveyed through my presentation. And we provide training as well. So if there are installers in, you know, local areas that haven't used our system before, we send our guys out to train them, right? We want to make sure that the installer is getting the benefit of our system. And we go out of our way to make sure that, you know, there's as much hand-holding as necessary to make sure that they understand how to use it. But really, it's, you know, it's attaching a vertical, making a couple adjustments if necessary, and yeah. But yes, I have, you know, a network of installers throughout the country. I can say Jackson Hole specifically. I know some people that would definitely probably go out there. I don't know anyone in Jackson Hole, but if there are, I can always reach out and definitely network to find someone that we would work with, no question. Yeah, you don't have to be like a certified installer to use our system, and we definitely will go out of our way to help train them up. So.
All right, next up, so Tim says, we typically want a full system warranty from one source, including WRB out to panel on our Rainscreen systems. What part of the wall assembly do you warrant?
So Bruce, you may want to chime in on that, but as far as I understand it, we warrant our system, right? Look at panels have a different warranty than we do. But we'll match, you know, whatever warranty is necessary. But you know, we're working on a project right now where, you know, a lot of times the installer warranties the actual work from, you know, weather barrier out. I mean, there's, you know, that project in LA, they have everything is weatherproofed, and our hangers are up, and then the installer for the stone comes back after everything's weatherproof. So that wall is warranted by whoever did all the weatherproofing, and they're coming back and doing the stone. So there is like a delineation of I guess responsibility there. But our standard a 10-year or
Yeah,
20
we
years?
have a our specific product within the Rainscreen assembly has a 10-year warranty on it.
Awesome. All right, great. It looks like that might be our only question for now. So we do have a few more moments left. I'll give everyone another minute or so to see if there are any last minute questions that come up. While we do that, I just want to show you all something pretty cool that I mentioned at the top of our call. So if you joined a few minutes late, you may not have caught this, but I'm going to give everyone just a quick preview of our new AI search. So I just was testing this out a little bit during our presentation earlier. So at the top of our call, I mentioned, we can search through multiple different types of resources on Acelab. So you can just do a product search. You can search for a manufacturer, search through our help articles and our resources. And something we just added last week is our new AI Copilot search. So you can click on this toggle to ask our Copilot anything. So I went ahead and I asked the Copilot for some recommendations on cladding attachment systems. And what's really cool about this is that it will ask questions back to you to help narrow down your search and make sure we're getting you the right products that you're looking for. So I asked for a cladding attachment device that could be used for various materials in a Rainscreen assembly, not the entire system of the Rainscreen, just the attachment pieces. And then our Copilot responded back, asked me how much adjustability I would need. I said I need moderate adjustability. And then the Copilot goes ahead and updates search results, highlights a few key products. So we've got both of Tion's products that showed up here, along with some other options from Monarch as well. And then you can just kind of continue with this search to help continuously narrow down your product choices. So just wanted to give y'all a quick preview of how this works. I think it's a pretty cool tool, really helpful to, help you identify, make sure you're asking the right questions when it comes to your product research. So definitely recommend everybody take some time to play around with that after today's call.
That is pretty
All
cool.
right. Yeah, it's awesome. We're really excited about it. It actually got released earlier than we planned, so we had it just in time for the AIA conference last week. Got to try it out live with some architects there, which was really fun.
Nice.
All right, we do have a few questions that came in. We've got about 3 minutes left, so we'll see if we can get through these quickly. All right, how long has an exterior installation been in place?
Oh, over 10 years. Yeah, I don't know. I have to go back and check the date, but over 10 years.
Awesome.
Past the warranty, put it like that.
Yeah. All right, and then next up, are your materials suitable for oceanfront environments?
Yeah, of course. Yeah. So we can treat the metal however we need to. If we need to anodize the aluminum, we have projects in Miami, Bay Area, Dubai, right on the ocean. So yeah, absolutely. All of our components are stainless steel. So yeah, we can treat the metal however we need to. Obviously when we go through engineering, we look at all the seismic, wind loading, weight, of course. Our products are installed obviously in San Francisco, out to Miami and all over the world. So we account for any kind of project specific condition.
Awesome. All right, great. Well, it looks like that wraps up our questions just in time. So just want to thank all of our attendees today for coming out and participating, asking so many great questions. Feel free to grab any of the resources from the chat you might need. We've got a link to the Tion page on Acelab. There's also the address for that YSL store. So if you're in the Toronto area, definitely go check that project out, maybe do some shopping. All right, Ben and Brewster, thank you so much for an excellent presentation. Always a pleasure to have you guys. We
Thank
really
you.
appreciate your time today.
Thanks, Bo. Thanks, everyone. Appreciate it.
Thank you.
Bye,
Have a good
everyone.
day.